Hello, pleasure to be here. So I run this submarine in Honduras, right in the middle of Central America, off an island called Roatán. And I've been there since 1998. And the submarine I'm operating, I built myself, and it's the second one. And I'm here today to share mostly underwater pictures, images, give you an idea of things that live down there, and also just a little bit of background on how I built the submarines and a little bit on where the submersible industry is as a whole. So something that, to put in context, is there are very few places in the world where people actually have the ability to see with their own eyes what's going on in the deep ocean. The majority of vehicles that are doing this are run mostly by first world governments. Actually, so there's been, in the 20 years, I would say there's been an abrupt change between 20 years ago, the majority of the vehicles that were going, say, 2,000 feet under the ocean were run by a handful of first world governments. Today, the majority of vehicles that are capable of going 2,000, 3,000 feet deep are actually run by private individuals. It's been, the submersible industry is kind of a microcosm of what's going on with funding for science overall in the world, I believe. So with the exception of China and India, China now operates the deepest submersible. It's only been built and tested maybe 3 years ago, but they're going 7,000 or 7,500 meters, and India is working on one that's going to be the second deepest one in the world. To put it in context, 20 years ago, the United States, on a government level, was operating 5 deep-sea submersibles, and now there's only one left that used to do 100 to 200 days of diving a year. Last year, they only did 60. So on the flip side, there are machines like this one that there's 5 companies now, one out of Florida, California, Europe, that are offering basically toys for people to have on their mega yachts. This is another one. This company has made over a dozen. They actually have a small assembly line going. So if you're in that market, it's a booming time. This is a boat that's operated by a foundation started by Ray Dalio of hedge fund fame. And also, if any of you have seen the new Blue Planet series, this boat, they have 2 subs on board, and they're really, in terms of images that are out there that people are seeing now of the deep sea from a manned sub, this is kind of the flagship in the world. But it's basically privately funded with personal money. So in the middle of this, my little niche that I've carved out, it started with a dream when I was 9 years old, and I started building my first sub when I was 15. And then offering trips to the public really just became, it evolved into that in terms of having a way to keep the things sustainable financially. But now it has become the world's premier location for the public to have cost-effective direct access to the deep water. It's the deepest one in the world the public has the ability to book a ticket on. I'm taking people to 2,000 feet. So this is, I grew up in New Jersey, just 40 minutes or so from here. This was in 1988. I'm 15 years old there. There's my dad looking on. He joked that it was the pipe in the yard. And it was for a number of years until I brought it down to college in Florida and finished it up there. And this sub carried myself and 1 passenger. It was extremely small. In terms of displacement, that tells exactly with a submarine how big it is, because it has to be able to achieve neutral buoyancy. So basically an aquarium of that same volume. 2,300 pounds. There's some one-person vehicles that weigh that. So it was very small. Not everybody could fit, but it was successful largely because of its small size, because it was very cost-effective to operate. And I ran that for, well, solidly for 2 years, taking passengers, and a max of 700 feet. So I left to go do a salvage contract in Cuba, and then when I got dropped back off in Florida, I realized this was becoming my career, and I was going to need a bigger boat. So I started designing around 2 upcycled parts that I was able to obtain, the forward sphere and the large dome window, both of which would have been out of my budget by themselves if I had to buy them new. But I designed around those. This is the only sub ever made of 3 spheres of 3 different sizes, or 3 spheres joined in an L configuration like this. And the passengers sit side by side up front, and I'm standing up in the back driving. And this is actually a really good arrangement because I have the ability to look complete. I have awareness of everything around us, including looking up, but the passengers get closer to animal life. You're going to see some of the photos later. They're all taken through the dome window that the passengers are looking through. But we also have an overlapping field of vision where I'm able to see the animal that we want to observe in relation to the window, so I can get the passengers extremely close. So this was my scale model. I originally designed it without the aid of computer design, or it was a little bit of trial and error and a little bit of educated guessing, but done on a very basic level. I did all my own welding, a lot of my own machining. I built it in a town called Idabel, Oklahoma. The vehicle is named after the town. The people there were incredibly supportive, and it's a small town in a very rural area of Oklahoma, so it was kind of famous there for a bit, and it worked out great too. There was a 200-foot deep lake that I was able to test it in. Here's the components being heat treated in a facility in Louisiana. So after you do welding on something, picture like if you put dried glue on a balloon, and the weld will, as it's heating and contracting, induces stresses into the metal. So if you want it to be extra strong after you're done with all your welding, you bake it in an oven at a certain temperature, and that allows the tension from the welding to relax. That's what's going on here. And there's the finished pressure hull in primer and paint. So the new vehicle, it carries myself and 2 passengers, though ultimately that's decided by weight. You have about 460 pounds for the passengers. The record is 6. That was a family with a bunch of small children. And it's made over 1,500 dives as deep as half a mile, and is right around 9,000 pounds, so a little more elbow room in there than the first version. There it is underwater. So, does anybody know what these animals are? Yeah. Most of the people that, so I see these on every dive. They're one of the oldest forms of life on the planet. They're in the fossil record, 500 million years, which is 10 times, almost 10 times as long as the dinosaurs were around, and they've been unchanged. Most of the people that I've had as passengers that know what they are, it's because they are into studying fossils. And basically, they're going to survive. They only live 500 feet or deeper, and they're relatives of starfish, and they can walk around. And there's a whole bunch of them on a limestone arch That's at 1,200 feet. And this is a close-up of the terrain between 300 to 600 feet where I'm diving. It's a vertical trench wall. I'm on the edge of the Cayman Trench. And there's basically a band of rock around most places in the world that looks very much like this photo here, that is a drowned ancient reef from when sea level was 450 feet lower than it is now. So when the sea level was that much lower, the shallow water reef was growing there, which puts a layer of limestone on things, which is what this is. And but then when sea level rises, the coral reef dies, and then the rock that it created slowly dissolves and makes something that looks like this. So actually a lot of the shallow water reefs around the world, if things continue at the pace they're going, may one day look sort of like this. To give you a sense of scale, the corals on here, the white ones, are 1 to 2 feet across. Something else that's very surprising to people when they take trips with me is the clarity of the water. People think that it's going to be very dark down there. But actually what happens is at about 300 feet, there's a major thermocline, and the visibility of the water skyrockets to the point where you can see 300, easily you could see across this whole room with natural light 1,000 feet underwater. And I've seen the surface from 600 feet. So these are Sixgill sharks. I've done close to 100 dives with bait where we go at night and have the bait. We used to stick it out at the end of a pole, but I've developed enough of the sharks, their metabolism is very low. The water down there is below 50 degrees, so they're not super aggressive. They're big. To give you a sense of scale, in this photo, that window is 30 inches across. So these sharks, they get 16, 18 feet long. And I've had a theory for years that nobody that I've spoken to has even been able to offer an alternative. But these are most likely the most numerous animal over, say, 200 pounds left on the planet today outside of humans and their livestock. They're found pretty much worldwide, but in tropical waters, they prefer to be 3,000 to 5,000 feet during the day. So they have basically been left alone. They're too big for people to, it's not worth the hassle yet for people to fish them that deep and pull something up that big from that, that heavy from that deep. This Jeremy Wade, about a year ago, we shot an episode of River Monsters. We had an 80-pound pig on the bumper there. We did a series of dives to film the Sixgills. And again, to give you a context of scale, we had a GoPro in a custom housing on the end of a carbon fiber pole that got this shot, and you can see the sub relative to the size of the vehicle. And can we play that video now, please? That sound in there, the scratching noise, was actually their skin against part of the sub. They have surprisingly tough skin. I've attempted tagging them, and they're very tough. This was a dive I did with National Geographic. This was, we were lucky enough to come across a horse that met an unfortunate end. We had 5 sharks in a feeding frenzy, but again, you can tell the size scale in that photo. And that was, the shark was large enough it was able to swallow the entire horse leg in one bite. And there are deer on the island. My neighbor keeps a few as pets. One died of old age, and I did a shark dive, and that was this photo. The shark was able to eat the whole deer in one gulp. So this is another kind of shark that I might actually have more direct observations of than anybody ever. They're only about 2.5, 3 feet long, and they live starting at around 1,000 feet, and they have these 2 big dorsal fins. The forward one has a poisonous spike in it, and they have a mouth kind of like an eagle ray, where they dig in the sand for things that are buried in there, and they crunch them up. That's a lucky shot. Sometimes I do a dive with a GoPro on 1-second time lapse on the front bumper, and just by chance got that shot. So in that photo, you can see the underside of the shark has those ribs. Much like a hammerhead's head has the electromagnetic sensing that it can detect, like, say, a ray buried in the sand. This shark, instead of just its head being like that, the entire underside of its body is like that. So in this low light environment, it's able to sense small things buried in the sand. And this, I believe, is the only photo of a baby rough shark. I've only seen 2, and this is the better photo. This is a Dumbo Octopus. They swim with their ears. They only start at around 1,800 feet. 1,800 feet is a significant depth. That's where it's really getting down to total blackness, which is not only the majority of this planet is covered by water so deep it's never seen sunlight, but also by volume. You're talking something like a 700 to 1 ratio volume-wise. The living space of this planet is really cold, dark water. So a lot of animals, that's specifically what they're evolved for, and this is one of those animals. This is a deep water coral. The red thing on there is a starfish, and that's about 2 feet in diameter. Very little is known about deep water coral. We're just starting to study it now. A few countries are putting some resources to figuring out what they have in their territorial waters. But what they've learned so far is that there may actually be more area of deep water coral than shallow water coral, despite the fact that a majority of it might have already been destroyed by trawling. But there are certain areas where the habitat is so jagged, where people avoid trawling, that is relatively untouched. And in those areas, it's this completely separate deep water environment that rivals a shallow water reef. But usually these start at around 600 feet is kind of a shallow one. The ones by me, they really start more around 1,200 feet. So there's that barrier to entry that has kept them from being better studied or well known. This is a type of sea cucumber that can swim. This is a chimera that's half shark, half ray. They have no cartilage. That's the animal my logo is based off of. This is a predatory jellyfish called a siphonophore, and they have stinging tentacles. They can catch small fish. Certain types of siphonophores can be 100 feet long. That's a jelly-nosed eel. They get to about 5 feet long. So this is a aerial view of the island where I live. And you can see that there's not a... So where that boat is on the left, that's already 400 or 500 feet deep right there. Basically, the island is surrounded by incredibly deep water. And actually, part of the reason I'm here is like a little bit of thank you to the Schmidt Ocean Institute, which, with this boat, the Falcor that they run, they had been doing a project in the Cayman Islands, and then were relocating through the canal. And a scientist that had worked with them had worked with me and realized that there was a unique opportunity here to do some multi-beam sonar work, which is usually would be the very first thing that would be done before putting any assets like a submersible or an ROV in the water. In this case, I'd been operating for more than 10 years when I was able to finally have a map. So this is the map that the Falcor generated. Well, they generated raw data, and then they gave that data to an undergrad student of this scientist, and then a couple months later, they made this map. But basically shows major erosion channels, features. Basically, after more than a decade of driving around down there, basically the blind man looking at an elephant, I was able to see a photo of the entire elephant for the first time. So it was amazing that worked out like that. And to give you an idea of what kind of detail a map like that can do, those lines are 100-foot increments, and the dark spots are boulders. So thanks to this map, I can actually have a map in my lap when I'm driving around down there and know exactly where I am relative to other features. And also, it enables me to find better areas that are conducive to things like deep water coral. In this example, those red circles are boulders that are 50 to 100 feet high, and they're all completely covered with deep water coral, which sets off a whole community of life. I mean, where there's rocks covered with coral, you have more everything, like very unique habitat. So actually, the biggest obstacle to more life being down there is sedimentation. So on the top of there, you can see it looks like big lines coming off. Those are erosion channels that are up to 600 feet deep. Everything being so steep, erosion is a major factor. Sometimes you even see what looks like waterfalls of sand coming down vertical areas. So that hinders life being able to take a foothold. Picture, a plant trying to grow on the scree side of a mountain where there's a glacier moving. That's a similar situation to what's going on here. Actually, right down to blocks of rock peeling off the wall, much like a glacier calving. There's limestone blocks, even at 2,000 feet, bigger than this room, that the very fact that it's limestone shows that it was made by coral. So the deepest that it fell from was 700 feet, and it broke free and rolled down there. So animals, when they can find boulders like that to get on top of, now they're out of that flow of sediment, and that's where they have their best chance of surviving. And if you get a bunch of boulders like that in one area, now you have critical mass for a whole community to really flourish. So those are the kind of things that I'm looking for with this map that the Falcor generated. And so because of that map, I've now made this device, which I call the Sled. And the submarine docks in there. This floating sled, it's made out of fiberglass and PVC fiberglass reinforced board, and it has 3 ballast compartments. And basically, you can put it in the water, flood the tank so it sits real low, drive the submarine in it, then partially inflate the ballast compartments. And you can tow from the submarine itself. The water pressure keeps the sled pushed on the front of it. There, the two of them are mated together. And now instead of towing at about 3 miles an hour, I can tow at about 7 miles an hour. And in addition to that, it makes it a lot easier to get in and out of the submarine in the middle of the ocean, which was basically unsafe in anything but super calm seas previously. But with this arrangement, you can get in and out in about 4 to 6 foot seas. So basically, thanks to the map that the Schmidt Ocean Institute generated, it's opened up a new era of exploration for me around Roatán to go and explore new spots. And there's a parting shot of Hammerhead cruising down the wall. And now I have another video that I'll talk through. It's a lot of the same animals we've seen, but you'll see how they move, and then we'll have questions. You only really need to hold the hatch tight enough just to put pressure on the O-ring to seal for the first couple feet, and once you get underwater, the pressure seals it for you. That's cruising along the top of the second wall, which is also where the thermocline is. There are a lot of animals, pelagics, like different kinds of sharks, mantas, tuna, that's your best chance of seeing them is along the top of that second wall. That's a type of deep water sand tiger shark. This is a pyrosome, which this one's about 8 feet long, but they can get over 20 feet long. And they actively swim. They're called pyrosome because pyra for Greek fire. They're capable of making very bright bioluminescence. This is at about 500 feet, filmed with only natural light. Everything looks very blue down there with no artificial light because that's the only color left in the light waves making it down there. This is another kind of siphonophore that you only start seeing at around 2,000 feet, and they connect themselves to the bottom with little tentacle arms about 3 feet off, and if you get close to them, they swim away. And this is a wonky-eyed jewel squid. They have, this is another kind of fish. Those are squat lobsters on a sea fan about 8 feet across. This is a nudibranch that's about the size of a football. They live pretty much only between 700 to 1,000 feet and are nocturnal. And if you hang out by them too long and disturb them, they jump off the bottom and swim. This is a giant isopod. They can get about 1.5 feet long. When I go with bait for the sharks, they often show up. And this is a polychaete worm. They're very common on sandy spots below 1,000 feet. They look like a little yellow slime ball, but then can jump up and swim. This is an orange roughy, one of the worst fish to eat. The only way they catch them is deep water trawling. They live over close to 200 years old. This is a sea cucumber. They're very common. Some dives, I might see 100 of them. And usually they just sit on the bottom, but every once in a while, they get a sniff of some food somewhere and they jump up and swim for a while to relocate. This is the Dumbo Octopus in action. This is a Sixgill again. Scientists like to have these scaling lasers on the sub. They're 10 centimeters apart. So like right now, you could freeze a frame of that and measure everything on the shark precisely. So what looks like worms on there are actually starfish called snake stars. And they have symbiotic relationships with the corals. This is a kind of anglerfish, and they have 4 legs and a little lure between their eyes. They can swim, but they prefer to waddle. That's the same type of starfish we saw in the still of the deep water corals. They're brisingid starfish. They're Pacific and Atlantic. And this is a Venus flytrap anemone. This is a sea robin. It's got prongs on its face that it can dig in the dirt with, and its pectoral fins have evolved into claws that it pulls itself along the bottom with. This is another kind of siphonophore. When you first approach them, they're in like a spiral chandelier. That's about a foot long at about 2,400 feet. I think that's it. Any questions? Yes?
Yeah, thank you for your talk. I'm in awe of your engineering abilities. How do you not die when you do these things? I mean, what is your approach to safety? How have you learned to make these dives safe? And what kind of sort of redundant safety measures have you built in your submarine?
Well, so the way that I educated myself on how to build a machine like this and not die was going and meeting with as many people as I could that had expertise at doing such things, and also physically looking at other vehicles and basically taking careful notes on how they were constructed. One thing that really works to my advantage in this, the first one was a cylinder, and the new one is a series of spheres. But basically, if you're going to go below a couple hundred feet, you have to be some combination of cylinders or spheres, the circular shape. And it's a scalable problem. So you can, and there are only a certain types of steels that are preferred to use for pressure vessels. So your variables are fairly limited in terms of what you're left with is, you can extrapolate, all right, this submarine was made out of that kind of steel, went this deep, and was a circle of this thickness. And it was really kind of engineering from that where I managed to, build a safe craft. Redundancy is a big thing in submersibles. So I weigh my passengers before they get in, and when we flood the ballast compartments, we're only sinking by maybe 10 or 20 pounds. And then we have 2 separate high-pressure air systems where we're able to add air to 2 separate ballast compartments where we could gain over 1,500 pounds of buoyancy. And we also have a single bolt we can turn and let loose about a 350-pound block of lead. We also carry 3 days of air. And the submersible also has fully redundant propulsion systems. Because of where I operate, most submersibles wouldn't have fully redundant propulsion. And if they had a motor failure, they would simply surface and call their support ship. But I'm operating without a support ship, so because of where I operate, I'm only 800 feet from the dock to the trench wall. But the flip side of that is if I came up and the wind was blowing me back towards the reef, by the time a boat came to tow me in, I might be up on the reef. So in addition to those other things, I have separate battery banks, 4 motors when I only need 2, separate switching. And so even though the motors I use aren't the most reliable kinds, they're brushed motors instead of, you could spend 10 times the amount for brushless motors. But I have motors fail maybe once or twice a year, and my passengers never know because I have a complete second set.
Thank you for coming in, for presenting to us. 2 questions. What was the best and the worst moment for you during the dives?
Well, the best moments are when I see things that I've never seen before, and that sense of discovery and awe and just not knowing what you're looking at, which I think is, in like a way, I'm a little bit envious of people that traveled before photography, and you only had, like a rough sketch, or you even imagine being like the first people crossing the continent on wagons and coming across the Grand Canyon and not even having a full concept of what you were going to see, versus like now you can look at somebody's photos on TripAdvisor and like pretty well understand what it is before you ever left your house. In the deep ocean, you can still have that sense of awe and discovery because they're literally, I've discovered new species with scientists that they're flipping out and they're the world experts. The worst moment I've ever had in the sub was I surfaced after about 6-7 hours from a shark dive at night, and the weather had deteriorated to the point there was probably 8 to 10 foot waves that were almost rolling the submarine completely over, and I had to get through the channel, which is about as wide as from me to you. And in addition to all that, there was a power outage on shore, so I had a compass and I knew I was looking straight at the island, but I couldn't see it because all the lights were out. But I didn't realize that. I thought it was in addition to, all right, these waves are bigger than anything I've ever been in, and the waves are so big, they're blocking my view. So that was fairly terrifying.
Hi, thanks for coming out. I saw Chasing Coral last year, and that was really hit me hard about the impacts of climate change in the ocean. I was just wondering if you've actually personally seen any changes in any of the dives you've done over the last few decades that you think are attributed to climate change?
We just had our first bleaching event where I live, but fortunately, the corals off of Honduras are doing a pretty good job of rebounding. The reef is relatively healthy compared to the rest of the Mesoamerican reef. However, in the 20 years that I've been diving, I would say I have definitely seen a marked decline in large pelagic species, or like tuna and hammerhead sharks. I think their numbers have come down 90% in 20 years. And on the flip side, the amount of plastic in the ocean is skyrocketing, and I definitely see evidence of that.
I read on your website about how you had a failure with a window cracking, and I was wondering if you could tell us about that and maybe why you think the window cracked. Like, what was the failure mode there?
Well, I'm not sure which story was on the website. There's been actually multiple windows cracking, but the that one was the first sub, and I designed it for 600 feet, and then I kind of kept pushing it and took it down to 725 feet, and shortly thereafter, actually on the way back up, was the first window cracking and the most dramatic of all of them, where it basically cracked right through the middle and water was spraying in the passenger's face. But we surfaced in a couple minutes with maybe 5 gallons of water in there. I had the presence of mind to take his camera and wrap it in a towel. Nothing got damaged. But basically what happened was the entire hull was being tweaked to where the window wasn't being pressed flat against the surface anymore. It was being twisted, and that was what caused the failure.
So when the submarine was coming up, it untwisted very quickly?
No, it's there's a time factor. Basically, like, had I just stayed at the 20 feet deeper a couple minutes longer, it still would have cracked. It was with plastic, much like glass windows eventually like start getting droopy on old enough buildings. A plastic window on a submarine, let's say at 1,000 hours underwater, it's actually half as strong as it was when it first got down there. So it was the time factor.
Hi, thanks for coming. The island you chose, what's it called?
Roatán.
It's beautiful. What other locations would be ideal? Like, if you couldn't go there.
Yeah. I've invested a great deal of energy looking at other locations and traveled to a good number of them as well. And Roatán is actually pretty close to the ideal location. You need deep water close to shore, preferably on the lee side of an island, no strong currents, close to an international airport and a customer base. And most of the other places around the world that have those things already have a cruise ship port, a commercial shipping port, military, like for example, the tongue of the ocean in the Bahamas, great location. There's been a military Navy base for submarines there since, I think, the 50s. Bahamas has great spots, but has cruise ships. So there was another operation in the Cayman Islands. And for example, when they were operating there, they had to share the same harbor with all the commercial traffic for the island. Whereas the bay that I operate out of, so the island has so many natural harbors, I would say 30 for a 40-mile long island, that every entity has its own harbor. It's really an ideal spot.
And how long does it take to fly there from here?
2 hours.
That's really close.
Yeah.
Yeah, awesome.
Maybe 2 hours from Houston. We have direct flights from Miami and Houston and Atlanta.
You talked in the beginning of your presentation about the advancements that have been made in the last 20, 30 years since you first started doing this. Curious to hear what you think in the next 20 years, what the next big thing is to happen in the industry.
I think 3D printing has enormous potential for making a hull that, picture like a bird's bone and how it's a matrix of mostly space, but has an internal truss that's giving it incredible strength and lightweight. The limiting factor on how deep a submersible hull can go is strength to weight ratio, and that's why some submersibles, well, they're testing one right now that's made out of carbon fiber that will be for 4,000 meters and will be the deepest privately owned vehicle of its kind. Carbon fiber has a lot of potential, but if you could do something like 3D print out of titanium or aluminum, or you would have something that could go almost full ocean depth very affordably. Right now, all the 6,000 meter submersibles rely on a titanium sphere, which is millions of dollars to create, extremely technical to weld, like has to be done in a vacuum chamber with a laser beam, and is still won't float. So to counteract all the weight of that sphere, they have to use very expensive foam that has glass microspheres in it. And then you've added you basically doubled the overall vehicle weight by just putting all this foam on it, just to counteract the weight of all the metal you had to put into the hull. If there was a way to make 3D print that where maybe it was 3 times as thick, but it was mostly airspace and internal trusses, which would be a nightmare to, manufacture in any traditional way, that would be a major breakthrough.
Hi.
Hi.
So you bring a lot of like civilians down to the bottom of the ocean.
Yeah.
I read on your site that to like see one of those 6-gilled sharks, you've got to be prepared to like be down there in total darkness for like 8 hours. Do people freak out on you? I'm like getting claustrophobic looking at this slideshow.
No, I've actually never had anybody freak out underwater. Every once in a while, somebody, when they first get in on the dock, they get back out. But I think they, they've been on the website, then they know what they're in for. And actually, even though it's a confined area to spend that amount of time in, and it's cold and a little uncomfortable, when that shark swims by, all of a sudden it feels like a very safe place.